Let's move on to the next one, that is 22nd question. Sn and Tn are given some series and another series given equals alpha T100. Now we can write Sn as simply 1 minus q to the power n plus 1 upon 1 minus q. So let's start this question. Sn is 1 minus q to the power n plus 1 upon 1 minus q, and Tn is equal to 1 minus q plus 1 by 2 raised to the power n plus 1 by 1 minus q plus 1 by 2. Another series given to me is 101 C1 plus 101 C2 S1 and so on. So I can read it as simply 101 C1 plus 101 C2 into 1 minus q square upon 1 minus q and so on till we have 101 C101 into 1 minus q raised to the power 101 upon 1 minus q is equal to alpha into T100. Right. The first term I can consider as multiplied with 1 minus q and divided with 1 minus q, so that I can separate it as simply 101 C1 plus 101 C2 and so on up to 101 C101. This is clear. Next, minus. Next we have q into 101 C1 plus q square into 101 C2 plus and so on up to 101 C101 q raised to the power 101. This is clear. Now entire term had denominator 1 minus q, that you can take on the other side and can write as 1 minus q multiplied with alpha into T100. Let's write down T100 only. So this is simplified as this first term is simply 2 to the power 101 minus 1, 2 raised to the power 101 minus 1. Second term is, you can see, as another binomial series. So this can be written with minus sign 1 plus q raised to the power 101. First term is missing, so need to write here minus, which becomes plus 1, right, is equal to 1 minus q multiplied with alpha into T100. Let's see what is T100. T100 is simply 2 to the power 101 minus 1 plus q to the power 101. So right here multiplied with 2 raised to the power 101 minus 1 plus q raised to the power 101 whole divided by 1 minus q, right. This is multiplied now with 2 raised to the power 100, right. Why so? Because you have in denominator 2 minus q minus 1, that is 1 minus q. This 2 is cancelled, so we are left with 2 to the power 100 in denominator. Now you can see here this 1 is cancelled. We have 2 to the power 101 minus this term, same as here. 1 minus q is also cancelled. So what is alpha here? Alpha is obtained as 2 raised to the power 100. So let's see from the given options. 2 raised to the power 100, that means option number 4 is the correct answer. Let's move on to the next one, that is question number 23. Length of lattice rectum of an ellipse with its major axis along x-axis and center at origin be 8. Length of the lattice rectum, that is 2b square by a. So let's write down this data. 2b square by a is 8. Next, if the distance between foci is equal to length of the minor axis, that is 2ae is equal to length of the minor axis, that is 2b. Next, then which of one of the following point lies on the ellipse? So we need to find the equation of ellipse first. We have 2b square is 8a, we have b equals ae, right. Also we can use one equation as b square is equal to a square into 1 minus e square, eccentricity equation. Just simplify the data to get the value for a as 8 and b as simply 4 root 2. Simplifying, we get this result, and therefore we can say the equation of ellipse is x square by 64 plus y square by 32 is equal to 1. Equation of ellipse. From the given points, when you substitute one by one, say for example option number 2, that gives you, on substituting x as 4 root 3, this becomes simply 16 3s are 48 by 64 here, and when you put here you get 8 by 32, right? Adding the two, the equation is satisfied. So correct answer for this question is option number 2. So I am sure this question is clear how we solve it. Let's move on to the next one, that is 24th. Let S 1, 2, 3 up to 20, a subset B of S is said to be nice if sum of elements of B is 203. Clear? Then the probability that a randomly chosen subset of S is nice is. So let's start this question. When you talk about sum of all the elements, you can see this is coming as 20 into 21 by 2, that is coming to be 210. Now you are saying sum of elements is 203, then we call it as nice, right? Let's see, when you have sum of elements as 7, that is other than 203 out of the total 210. So sum 7 you can see is obtained as you have single element 7, you have elements like 1, 6, 2, 5, 3, 4, or you have elements like 1, 2, 4, that's it, because repetition is not there. So in such cases you find it is not nice at all. You find the sum is 7. Sum is 7. Now you are looking for sum 203. If element 7 is not there, it will be 203. If element 16 is not there, the sum will be 203, and so on. So in how many cases you find sum 203? Yes, it is in total 5 cases. In 5 cases you find the sum as simply 203. Now how many total? Therefore the required probability is equal to 5 upon total. Total meaning 2 raised to the power 20. So the required probability is 5 upon 2 raised to the power 20, that is option number 4. Let's move on to the next question, that is question number 25.